Hi guys, we're almost at the end here. Section 11.3, which is shapes of distributions. So here we go. So a shape of a distribution can be classified in three different ways. We can classify it as skewed to the left, symmetric, or skewed to the right. So symmetric, you want to think of something that the data on the right of the distribution is a mirror image as the data on the left. So that's what we're talking about in this example here, where it's has symmetry about it, meaning it's the same on the left side as it is on the right side. Now you can also see something like this, which could also be classified as symmetric. So you have a shape such as this one. That's also symmetric because it's the same on the left side as it is on the right side. My drawing's not so great. Now, in terms of skewness, it is skewed in the direction of the tail. So you see how the tail is over here? That means that it is skewed to the left. The hump is on the right-hand side. And when you have a skewed right distribution, your tail is to the right. And you always want to kind of draw in the curve to show that. Another way you could think of it is you could think of your feet. So if you think about your feet, I'm going to try and draw a foot in here. There's your big toe. And there's the rest of your toes. And notice that your right foot, where that's what your right foot looks like, is skewed to the right. And then same idea if you drew in your left foot is skewed left. So you can always think of your feet and look down at your toes, and you can see whether or not you're talking about skewed left or skewed right. So if we think about this graph here where we're showing a frequency table, so the frequency table shows the number of times that a data value is occurring. And first it says describe it or display the data in a histogram, and then describe the shape of the data. So to show the data in a histogram, you would use these as your tick marks here. And then you would just draw in on your y-axis would be the frequency. And on the x-axis would be the number of tickets sold. So I'm going to count up by fives here. Remember, you always have to have an even axis, meaning you're counting up by the same amount each time. And now over here, I'm going to have from 1 to 8. Actually, I'm going to do it like this. Yeah, and then I'm going to go 16. Then I'm going to go 24, 32. I'm just using the second value. 40, 48, and then 56. So a histogram is really just like drawing in like similar to a bar graph, except your bars touch. So we're going to go, our first bar is to 5. And this one goes to 9. This one goes to 16. 25. 20. 8. And 7. So we can see here, it's not perfectly symmetric, but if I draw my curve is going to look something like that. So the shape of the histogram here would be symmetric, okay? Kind of makes that mountain shape. That's the same on both sides with a single peak, so it's symmetric. I'm not going to go through the try this here. You can see where the hump is going to be. The hump is going to be over to the right. So you're going to end up getting a distribution that looks like this, which would be a skewed left distribution because the tail is on the left-hand side. So choosing appropriate measures of center and variation. When you have a data set that is symmetric, okay? When you have a symmetric data set, you want to use the mean and the standard deviation. When you have a skewed data set, whether it's skewed left or skewed right, you want to use the median And you want to use really the interquartile range to describe the variation. Okay, so when it's symmetric, mean and standard deviation. When it's skewed, median and IQR. Okay, so here you have a set of data here, and you want to make a histogram with that set of data, and you want to use the intervals beginning with 31 to 35. So what you would do is you would go through the data set, and your first interval is going to be from 31 to 35, and you would see how many of those you have. So you have one, that's it. So I'm going to count by fives again. So from here, I only have one. So I'm going to have a really small bar. And then I have from 36 to 40. So I'm going to make my next bar at 40. And how many do I have? I have 1, 2, 3. That looks like that's it. And then I have from 41 to 45. And there's plenty of data, things out there on the internet that could make these for you. 2, 3, 4, 5. And then I have from 46 to 50. And it's not a bad idea to make a table as you're doing this with how many you have, making that frequency table. So from 46 to 50, you have, let's see, 1, 2, 3, 4, 5. Then you have 51 to 55, where you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to erase this because I've run out of room. And then we have from 56 to 60, where we have 1, 2, 3, looks like 4. So if we're asked to describe the shape, which I'm sure we'll be asked to do next, or which measure of center, that shape? Well, if we ask the shape, we can see that it's skewed to the left. My tail is over here. So we know that this is skewed left. So which is a better measure of center and variation to use? We want to use the median and the IQR. And the IQR is part of your 5-number summary. If the speed limit is 45, we know that the majority of people are speeding. Okay, because the majority of our speeds were more than that or higher than that. Okay, I'm not going to make another histogram. You can do it online yourself. Example 3 says, okay, you have female students and their text messaging with the number of emoticons and male students. And you're showing 2 histograms here, and you're asked to compare their shapes and the appropriate measures of center and variation. So we can see here, this one is symmetric. This is skewed. My tail is on the right-hand side, so skewed right. So for the males, or let's do the females first, which was symmetric, we would use the mean and the standard deviation. Mean is your measure of center, standard deviation your measure of variation. And for the males, we would use the median because it is skewed, and the 5-number summary. And when we say 5-number summary, what we're talking about is we're talking about the minimum, Q1, first quartile, the median, Q3, your third quartile, and the maximum. So remember, symmetric distributions go with mean and standard deviation. Skewed distributions go with median and interquartile range or 5-number summary. Same idea here. This would be skewed right. Our professional football players use the median and 5-number summary or interquartile range. This is symmetric. Use the mean and standard deviation. Okay. Now you're asked to make a double box and whisker plot with the data, and you're asked to describe the shape. So when you're making a box and whisker plot, start with the axis, and our minimum value is 0, and our maximum, or 2 rather, and our maximum 24. So I'm going to count by 5s, starting at 0. And this is the number of shoes people own. So we always want to label our axis as the number of shoes. I'm going to put the men in blue. So I'm going to draw my men box plot. And the male box plot, remember you have a center box from Q1, so which is 5, to Q3, which is 10. Your median is somewhere in that middle box. In this case, it's 7. And then draw your whiskers to the minimum and the maximum. And the maximum is 17. And then for the women, I'm going to draw in red. Minimum value at, let me draw my center box in first. So Q1 is 12. And Q3 is 17. Median is 14. And we're going up to 24 and down to 5. So if we're looking here, we can see that our male distribution is definitely skewed to the right because this distance is bigger than this distance. Oops, let me erase that, not that distance. This one. So we know this is skewed right. Larger distance from Q3 to the max. So we would want to use the median and the IQR or 5-number summary. Oh, I lost my whisker for my women. For the women, though, the distance from Q1 to the min and Q3 to the max is about the same. So this distribution will be symmetric, and we would use the mean and the standard deviation. So this goes back to the previous lesson talking about box plots. You're looking at the distance from Q1 to the minimum and Q3 to the maximum to determine the shape. If we have a symmetric shape, mean and standard deviation. Skewed shape, median and interquartile range. If you're asked to compare the distributions, okay, like we are in B, we're not going to worry about C. You would want to talk about comparing the overall distributions. Where are they centered? So for example, the women had a higher median number of shoes owned than the men. The women had a larger range than the men. And we want to talk about the shape, skewed right versus symmetric. Those are all the things that you'd want to talk about when describing a distribution. Okay, that's all for today. So key things for today. Make sure that you're able to remember the shapes of distributions, skewed to the left, symmetric, and skewed to the right. Make sure that you're able to make a histogram. You can use plenty of online tools to help you do that. Make sure that you know that mean and standard deviation go with symmetric distributions. Median and 5-number summary or interquartile range go with skewed distributions. And then make sure you're able to know when to use each of those, when to be able to describe the shape by looking at a graph, and be able to make some box plots and describe shape and what goes with what from those as well. I just want to show you that if you keep this, that you can use some online tools to help you make histograms. So if you just go to like histogram maker and you just Google that, and there's plenty of tools on here that could help you to make a histogram. There's not really a good way to do it on Desmos, but like you can put in your data in here. So maybe can't copy any of it, but if you put your data in here and then hit generate, it'll make that histogram for you. So that's one tool. And again, you can just go to Google and you can find plenty of online histogram makers that could help you in actually making a histogram. That's it for today, guys. Good luck. We're almost at the end, and keep working hard. See ya.